Assalamualaikum and hi. Today's video presentation is about Physics 110 Experiment 3, which is measuring gravitational acceleration. This video is presented by me, Nur Syaratul Adawiah binti Yusri, and my friend Sofea binti Khairul Anwar. The objective of this experiment is to investigate the functional relationship between height of fall and falling time. The second one is to determine the acceleration due to gravity by studying the motion of a freely falling body. The apparatus of this experiment are falling sphere apparatus consisting of release unit, impact switch, digital counter, support base, ruler, support rod, connecting cord, and ball bearing.
The procedure that has been done was the apparatus have been set up as in figure 3.1. 3CT sphere is grouped in the release mechanism which closes the circuit. Next, the pen had been adjusted using the adjusting screw under the arrest switch. Is a way that the downward motion of a few tenths of millimeters closed the stop circuit. The pen had been raised by hand after each single measurement. The radius of the sphere must be taken into account for effective determination of the height of fall using the marking on the release mechanism.
Okay, now let's proceed to the experiment.
First of all, we must use a ruler to measure 50 cm from the platform to the releasing unit. The releasing unit must then be secured tightly so that it won't slip throughout the experiment. The most important step is to lift up the metal plate so that there won't be any major errors in the outcome. We put the metal ball at the releasing unit and press it until you're ready to release the ball. Before releasing the metal ball, make sure to push the 0 and start buttons on the digital counter. Once the metal ball is released, repeat the process 2 more times to obtain more precise and accurate result. Don't forget to record all the results. Repeat all these steps until the measurement reaches 10 cm.
So here are the results that we recorded from the experiment. From the results, we already plot graph for height of fall as a function of falling time, and a graph of height of fall as a function of the square of falling time. Then, we calculate the centroid of the graph. After that, we determine the gradient of the graph and search for gradient maximum and gradient minimum. After that, we calculate gradient uncertainties. Then, we use straight line equation and kinematic equation to calculate value of gravity. After that, we calculate the value of uncertainty of gravity, which is equal to uncertainty of gradient. Then we calculate the percentage error of gravity, and we also calculate the percent difference between the value of gravity calculated in experiment above and the standard value of gravity, which is 9.81 meter per second square.
In this experiment, we make use a variety of measurement tools, including a digital counter and a ruler. Come to the conclusion that this experiment has errors based on the analysis. It is possible that the experimenter forgot to press the 0 button on the digital counter. This could affect the result of the experiment. Same goes to the metal plate or platform. If the experimenter forgot to lift up the metal plate, thus, the end result can be inaccurate. To avoid this, the person must remind themselves not to overlook these important steps. The height of falling sphere apparatus with release unit might not be perpendicular with the scale of ruler while reading the scales. This occurred because the observer's eyes were not in the proper position. Therefore, it resulted in parallax error, which make the results inaccurate. To prevent it, we must make sure that while observing, our eyes are perpendicular to the ruler. To lessen the error in the results, this experiment can be improved by repeating it more than 3 times.
So, the conclusion for this experiment is the functional relationship between height of fall and falling time develops due to gravitational on Earth, which is constant. Hence, the acceleration due to gravity is free fall that occurs when the only force acting upon an object is only gravity. Based on our results, gravity is 9.86 meter per second square, which is fairly close to the gravity standard, which is 9.81 meter per square. That's all from us. I hope you enjoyed our video. Thank you.